I'm going to talk about the arcsine, arccosine, and arctangent functions. All right? People often say that these are the inverses of the sine, cosine, and tangent functions. That's true with respect to limited domains only. All right? You might know that even when you have a function that's not invertible, you can still define an inverse if you're willing to restrict yourself to a limited domain. All right? And that's what's done with sine, cosine, and tangent. Let me now specify the limited domains that are traditionally and commonly used. For the sine function, we restrict ourselves in order to define an inverse to values between minus pi over 2 and pi over 2 radians. And it just so happens the limited domain for the tangent is the same as for the sine function. For cosine, we restrict ourselves to angle measures or values between 0 and pi radians. Okay? And so with regards to those limited domains, we can define inverse functions. The inverse function of sine is referred to as the arcsine. For cosine, it's referred to as the arccosine. For tangent, it's referred to as the arctangent. And here's how people denote those functions. Now I'm using a different letter to remind ourselves that these are inverse functions. Okay, we take the sine, cosine, and tangent of angle measures, right? When we evaluate the arcsine, arccosine, and arctangent, the answers will correspond to angle measures, okay? Now, let's use these inverse functions to get some practice with them, okay? So, and I'll do a few using these special angles that don't require a calculator, although you can confirm these values with a calculator if you like. So the arcsine of 1/2, you can, if you understand the definition of arcsine, you can determine that the arcsine of 1/2 is pi over 6. One way to do that is to ask yourself the sine of what angle is equal to 1/2 with respect to the necessary limited domain, and the sine of pi over 6 is equal to 1/2. So that's how that could be determined without a calculator. All right? Let me do another one. The arccosine of 0, you can determine that with a calculator, or think about the definition of the arccosine and find out that the answer is pi over 2 because the cosine of pi over 2 is equal to 0. Okay, now let's be clear. There are other angles measures that have a cosine value of 0. Okay, for example, the cosine of pi over 2 plus 1,000 pi. That's also equal to 0. Okay? However, remember we need to choose the angle measure that corresponds to the limited domain that we've selected for cosine. So it's very important to keep those limited domains in mind. Okay? Let me have you try one now. Would you please pause the video and try to determine this without a calculator? The arctangent of 1. Okay, I'll go ahead and work it out now. So that is pi over 4. And I know that's true because the tangent of pi over 4 is equal to 1. Okay? Now, let's do some that require a calculator. And let's do, your calculator may have what's called a degree mode and a radian mode. So you can actually work with either units for angle measures that you want. Let's start with a problem involving degrees. So setting your calculator to degree mode, figure out how to determine the arcsine of 0.438. You should get something close to 26 degrees. Okay? If you don't get a number close to 26, you're not in degree mode. You're probably getting an answer in radians. And then you can also take the sine of 26 degrees to convince yourself that you're going to get a decimal close to 0.438. Now I'll change the equal symbol to an approximate symbol because those are approximately true. All right? Let's do one now in radian mode. If you know how to switch your calculator to radian mode, try to find the Arccosine of 0.697, and you should get 0.8. If you get something different than 0.8, you are not in radian mode. You're probably getting an answer in degrees, and you just don't know it. Okay, and then in radian mode, try to find the cosine of 0.8, and you'll see that you get something close to 0.697. Once again, let me change the equals to an approximate symbol. Okay, so let me show you some triangle problems where these inverse functions come in handy. Suppose you wanted to know the measure of an angle of a triangle. And it's a right triangle, and you only knew 2 side lengths. Let's suppose you knew that the hypotenuse length was 12 length units, and the horizontal leg length was 9 length units, and you wanted to find the value of theta, where theta is the angle measure of the left acute angle. Okay? One way that you could figure that out is first telling yourself, noticing that cosine of theta is 9 over 12. Okay? So therefore, theta is equal to the arccosine of 9 over 12. Or if you want to reduce the fraction, the arccosine of 3 over 4. Okay? Now, let me have you try one. So let me give you another right triangle. And let's suppose this time you wanted to find the value, the angle measure of the leftmost angle, and we'll call it, well, we want to find the measure of the leftmost angle, we'll call it alpha. And let's say this time you knew that the vertical leg length was 3 and the horizontal leg length was, let's say, 5. Okay? Pause the video and try to give me an expression equal to alpha. All right, I'll go ahead and do it. So the tangent of alpha is equal to 3/5. Therefore, alpha is equal to the arctangent of 3/5. Okay, and I hope that's the answer you got. let me now discuss how to simplify expressions involving arcsine, arccosine, and arctangent that you might see. Suppose you were doing some calculation and this came up. The arcsine of the cosine of 13 pi over 6. All right. Now, you could punch that into your calculator to get a decimal number. Let me show you how you can simplify this expression without needing a calculator. So, to understand what I'm going to do, you need to first realize that the arcsine of the sine of theta is equal to theta, assuming that theta is in the limited domain that we've specified for sine. Okay? The reason that that's true is because the sine and arcsine functions are inverses of each other with respect to a limited domain. Okay, if that's clear, then we can begin to understand how to simplify this expression. What we're going to want to do is replace the cosine of 13 pi over 6 with an equivalent expression involving sine. That's what I'm going to do right now. Why am I going to do that? Because then I can use that equation that I just wrote down. Okay, so now let's think about how to find an equivalent expression for cosine of 13 pi over 6. So the cosine of 13 pi over 6, first of all, we can add or subtract 2 pi's all day long, and we will not change the cosine value. So 13 pi over 6 is a little bigger than I would like it to be, so why don't I subtract 2 pi from it? So that's the same as subtracting 12 pi over 6, and that will give me the cosine of pi over 6, right? Now, you may know, using the complementary angle identities, that the cosine of pi over 6 is equal to the sine of pi over 2 minus pi over 6. Okay? And that's equal to the sine of pi over 3. Okay? Now, all of that was to now go back to the original expression and express it thusly. The arcsine of the sine of pi over 3. And that's equal to pi over 3. Okay? Now, let me repeat. You need to make sure that your answer is with respect to the limited domains we've specified. Okay? And the way that you can adjust the angle measures is by adding and subtracting as many 2 pi's as necessary. Or in degrees, adding and subtracting 360 as many times as necessary. Okay? Now, because this question involved special angles, you probably noticed that. You could have also seen that the cosine of pi over 6 was equal to the square root of 3 over 2. Okay, and so maybe that allowed you to see that that's equal to the sine of pi over 3. So there's a few variations you could have done, but at the end of your calculation, you have to get pi over 3. All right? Now, let me have you try a similar problem. Would you please pause the video and try to determine the arccosine of the sine of minus 11 pi over 4. Okay, do that now, please. Okay, I'll go ahead and work it out. So, to understand what I'm going to do, I'll spell it out. We need to be aware that the arccosine of the cosine of theta is equal to theta, assuming theta is within the limited domain that it needs to be. So we're going to we're going to replace this expression involving sine of minus 11 pi over 4, with an equivalent expression involving cosine. Okay, so let's do that now. So let me first add a 2 pi to minus 11 pi over 4. So that's the same as adding 8 pi over 4, and that will give minus 3 pi over 4. Okay, now the sine of minus 3 pi over 4 is minus root 2 over 2, which is the same as the sine of pi over 4, which is the same as, excuse me, it's minus the sine of pi over 4, because the sine of minus 3 pi over 4 is negative. So let me make sure to add a minus sign here. Okay, so I'm still trying, let's not forget what we're trying to do. We're trying to get an equivalent expression involving cosine. So what angle measure has a cosine equal to minus sine of pi over 4? In other words, equal to minus the square root of 2 over 2. All right? Now, there's a couple of answers you could say. Okay? We have to, again, I can't say this enough, we have to make sure to pick an angle measure that corresponds to the necessary limited domain. Okay? So we're going to want to choose the cosine of 3 pi over 4. All right? Now 5 pi, the cosine of 5 pi over 4 is the same as what I wrote down. However, 5 pi over 4 is not in the limited domain of cosine. Okay? Neither is minus 3 pi over 4. So be careful. Okay, so now we can rewrite the original expression as the arccosine of the cosine of 3 pi over 4, and we're happy. Or I hope you are. The arccosine of the cosine of 3 pi over 4 is equal to 3 pi over 4. I hope that's what you got. Okay, now let's do a similar one that involves a slightly different technique. Okay, so what about if we wanted to solve the sine, or excuse me, what if we wanted to simplify the sine of the arctangent of 7 over 4? Okay, now why don't you pause the video and see if you can figure out how to do that before I explain it. So try that now if you like. Okay, now I'll show you one way that you could explain how to simplify this. So I'm going to make up a name for define a variable called theta equal to the arctangent of 7 over 4. Okay, now let's take the tangent of both sides. So the tangent of theta is equal to the tangent of the arctangent. So the tangent of the arctangent of 7 over 4 is going to equal 7 over 4, because the tangent and the arctangent are inverse functions of each other, again, only with respect to a limited domain. And let's now rewrite the original expression as the sine of theta. So I'm basically looking for the value of sine of theta if the tangent of theta is equal to 7 over 4. Now, doesn't that seem a little bit easier? At least it does to me. Okay? So can I determine the sine value if I know that the tangent value is 7 over 4? Okay? Let's play with the tangent for a second. So tangent of theta is equal to the sine of theta over the cosine of theta. That's equal to the sine of theta over, and now using the Pythagorean identity, I'm going to replace cosine with this expression, the plus or minus the square root of 1 minus sine squared theta. Okay, plus or minus that square root will always be equal to the cosine of theta. Okay, for any value theta. Now, we need to determine whether we need to use the plus or the minus sign in front. Okay, here's how we're going to determine that. Think about angles that have a tangent equal to 7 over 4. Okay, with respect, angles be in the angle measures that have a tangent equal to 7 over 4. They have to be angle measures, and also we've restricted tangent to a limited domain that corresponds to the first and fourth quadrant. Okay, so let me ask the question this way: what quadrant, first quadrant and fourth quadrant, which one of those quadrants has angle measures that have tangents equal to positive numbers? I hope you can see that the first quadrant has angles that correspond to the first quadrant have tangent values that are positive. Angles that correspond to the fourth quadrant have angle measures that correspond to the fourth quadrant have tangents that are negative. So therefore, we know that theta corresponds to the first quadrant. Okay? If theta corresponds to the first quadrant, do you agree that the cosine must be positive? Actually, for the cosine is positive for both the first and fourth quadrants, isn't it? So we didn't even have to think that hard. We knew that the tangent is limited to the first and fourth quadrants, so therefore we have to go with the positive version. Okay, and furthermore, we know what the tangent value is. That's 7 over 4, right? Okay, well now that's just algebra. You can cross multiply, square both sides, and solve for the sine of theta. Okay? And if you do that, I'll just tell you what you would get. You would get that the sine of theta is equal to 7 root 65 divided by 65. Okay, let me repeat. To solve that equation, it's just algebra. You cross multiply and square both sides, okay, and work it out that way. Furthermore, the sine has to be positive in the first quadrant, okay, with respect to the first quadrant, and so you'll end up with another situation where you have to choose between a plus or minus solution, so you'll go with the plus solution. All right, I encourage you to do that if you haven't already. Okay, now let's do one involving variables and think about all the things I've said so far and see if you can solve this one. So suppose we wanted to simplify the cosine of the arcsine of x over 3. I'll tell you what, I'll do this one, and then I'll have you do another similar one involving variables. So let's say I knew that the x values were confined to values between -3 and 3. Okay, can we simplify this expression? All right, once again, let's do a variable substitution. Let's define theta equal to the arcsine of x over 3. Now let's take the sine of both sides of that equation. So the sine of theta is equal to x over 3. Okay, and we are looking for the cosine of theta. Okay, the original expression is equal to the cosine of theta. So if we can find the cosine of theta, when we assume, where we assume that the sine of theta is x over 3, we're good to go. Okay? So we know that the cosine of theta is equal to plus or minus the square root of 1 minus sine squared theta from the Pythagorean identity. You can derive that from the Pythagorean identity. So apparently the original expression is equivalent to plus or minus the square root of 1 minus x over 3 squared. Okay? Now we have to decide whether we have to go with the plus version or the minus version. All right, so let's again think about the quadrants. So the x values are range from minus 3 to 3. X over 3 ranges from minus 1 to 1. Okay, and the sine is restricted to the domain, a limited domain that corresponds to the first and fourth quadrant. Okay, like the last problem where we were focusing on the first and fourth quadrants. Okay, would you agree that the cosine of angle measures with respect to the first and fourth quadrants are always positive? Okay, so that's how I know that we can go with the positive version. And let me write it as x squared over 9. Okay, and so that is the answer. Okay, now let me have you try a similar one, and then we'll close with this one. Can you simplify the sine of the arctangent of 4x if we assume that we restrict the x values to values between minus a fourth and a fourth? Okay? Pause the video and try to work that out now, please. Okay, so I will show you how I would work it out. So probably the easiest way to explain it is with a new variable. I'm going to define theta to be equal to the arctangent of 4x. That means if I take the tangent of both sides, that the tangent of theta is equal to 4x. And the original expression is equivalent to the sine of theta. So I'm essentially looking for the sine of theta where the tangent of theta is equal to 4x. Okay, so can we figure that out? Well, we know that the tangent of theta is equal to sine theta over cosine theta, which is equal to the sine theta, which is equal to sine theta over plus or minus 1 minus sine of theta. Okay, and once again we need to determine whether we have to go with the plus or minus versions. Okay, let's postpone that determination for right now, and let's do this first. Let's set this equal to 4x because the tangent of theta is 4x, and then let's do the algebra to solve for the sine of theta. So square both sides and try to isolate the sine of theta. Okay, if you do, I'll tell you what you'll get. You will get, or what you got if you tried it already and did it correctly, you'll get that the sine of theta is equal to, sine squared theta is equal to plus or minus 6, excuse me, it's equal to plus, the squares always have to be positive, 16x squared over 16x squared plus 1. So you take this, you evaluate that using the square roots, so you get that the sine of theta is equal to, and then taking the square root of the top and bottom, plus or minus 4x over the square root of 16x squared plus 1. All right. Now, this is going to take a little bit of care. Okay. The sine, S-I-G-N, of the sine function is going to depend on the value of x. If x is positive, then the sine is positive. The sine of theta is positive. If x is negative, then the sine of theta is negative. Okay, why is that? Okay, if x is positive, the tangent is positive, and that corresponds to the first quadrant. If x is negative, then the tangent of theta is negative, and that corresponds to the fourth quadrant. Okay, and the sine is positive. The sine of theta is positive in the first quadrant and negative in the fourth quadrant. All of that is to say that the sine of theta and x will have the same sign. So therefore, we can just say that the answer is 4x over this. So drop the negative, the plus or minus in front. And we know that as x changes sign, the sine of theta will adjust accordingly. Okay? And I hope that's the answer that you got. Now, that was a mouthful, so you might want to watch that last part of the video again, maybe a few times, to make sure you understand all that. Okay?